5.1 day 2, we're going to use fundamental identities. We're going to recognize and write the fundamental trig identities. We're going to use these fundamental trig identities to evaluate trig functions, simplify trig expressions, and rewrite trigonometric expressions. So recall that in some cases when factoring or simplifying a trig expression, it is helpful to first rewrite the expression in terms of just one trig function or in terms of sine and cosine only. So we're going to see that in this next example. So we have sine of t plus cosine of t, cotangent of t, times cosine of t. So we want to simplify it. And so what we're going to do is we're going to go ahead and rewrite everything in sine and cosine. So the first thing just stays. Cotangent is cosine over sine, and then times cosine of t. So what we want to do is get a common denominator. So we're going to multiply the first expression by sine of t, or multiply that sine by sine of t over sine of t. So now this becomes sine squared of t plus cosine squared of t all over sine of t. Now remember, sine squared of t plus cosine squared of t, that's one of our Pythagorean identities, and so that just is 1. And so it's 1 over sine of t, and we simplify all that all the way to cosecant of t. So try this example. Cosecant of x minus cosine of x times cotangent of x. So for this example, the final answer is sine of x. So you convert everything to sine and cosine. And then, so that's 1 over sine of x, and then minus cosine of x times cosine of x times sine of x. I just multiply cosine and cosine. So that's 1 minus cosine squared of x, and remember our trig identity here. And so we know that 1 minus cosine squared of x equals sine squared of x, so I place that. And then I can cancel out one of these sine of x's, and so therefore my final answer is sine of x. Now let's add some trig expressions. Perform the addition and then simplify. So we have sine of x over 1 plus cosine of theta, and then cosine theta over sine of theta. So we have, let me just rewrite it. So what we want to do is we want a common denominator. So we're going to multiply the one on the right by 1 plus cosine theta. And on the left, we're going to multiply by sine of theta to get a common denominator. So now this becomes sine squared of theta plus so let's go ahead and multiply cosine theta plus cosine squared of theta all over 1 plus cosine theta times sine of theta. So one thing we hopefully notice is that you have a sine squared of theta plus cosine squared of theta. So let's group that together. And then plus cosine of theta over 1 plus cosine of theta times sine of theta. So remember, the sine squared of theta plus cosine squared of theta, that just changes to 1. So 1 plus cosine theta over 1 plus cosine theta sine theta. And then so you could write parentheses here, and I hope you see that you can go ahead and cancel those out, factor it out. So we have 1 over sine of theta, and 1 over sine of theta is cosecant of theta. So try this example. Perform the addition and simplify. So trying this out, you multiply by the conjugate, so 1 plus sine of theta on the right, and then on the left you multiply 1 minus sine of theta to the numerator and denominator, and then you notice the numerator becomes just 2 because it's negative sine and positive sine of theta both disappear. In the denominator, you're going to go ahead and multiply it through, and when you multiply that through, you see that you get 1 minus sine squared of theta. Then, you remember the Pythagorean identity, so we can substitute 1 minus sine squared of theta with cosine squared of theta. So now you have 2 over cosine squared of theta, and then that just gets rewritten as 2 secant squared of theta. So we're going to rewrite 1 over 1 plus sine of x so that it's not in fractional form. So one thing that I want to bring up, let's remember that cosine squared of x equals 1 minus sine squared of x. Okay, we use that a couple times. Then, on top of that, this is factorable. So 1 plus sine of x, 1 minus sine of x. And so we're going to use that. So we have 1 over 1 plus sine of x. We're going to multiply by the conjugate, 1 minus sine of x over 1 minus sine of x. So the numerator is now 1 minus sine of x over 1 minus sine squared of x. So we have 1 minus sine of x, and then the 1 minus sine squared of x becomes a cosine squared of x. And then we can separate this. So we're going to separate this as 1 over cosine squared of x minus sine of x over cosine squared of x. So just remember that this is allowed because remember, if they have a common denominator, I can combine them as to 1. So if you look at it, they have the common denominator, and we would put it back together to 1 minus sine of x. So that is okay. Now let's go ahead and simplify a little bit more. 1 over cosine squared of x, that just becomes secant squared of x. And then we have sine of x, so we can separate that a little bit. So that's sine of x over cosine x times cosine x in the denominator. So let's look at this. Sine of x over cosine x. So this is secant squared of x on the left. That becomes tangent of x. Then the cosine in the bottom becomes secant of x. So now it's not in fractional form. So secant squared of x minus tan of x times secant of x. So try this example here. Rewrite cosine squared of theta over 1 minus sine theta so that it is not in fractional form. So here you multiply by 1 plus sine of x to the numerator and denominator. And so the numerator is cosine squared of theta times 1 plus sine of theta all over, multiply this through, 1 minus sine squared of theta. Now remember, 1 minus sine squared of theta is cosine squared of theta, so you substitute. Then now you can cancel out the cosine squared of theta. So your final answer is 1 plus sine of theta.